A bag contains 10 jelly beans, which are either red or black jelly beans. 2 of the jelly beans are to be drawn simultaneously from the bag. If X of the jelly beans are red, what's the value of X? Well, this question is interesting. Okay, here we're not being asked to calculate any probability, but where's the probabilities here? Let's take a look at the statements. It says the probability that the 2 jelly beans to be drawn are red is 1/15, and the probability that one of the jelly beans drawn will be red and the other will be black is 7/15. So the probability is already involved in this calculation. How so? Okay, let's consider what we would do. We want to know what X is, but let's consider here. What is X? X is the number of reds. What is the number of blacks? It should be 10 minus X. That is the number of blacks. And 10 is the total number of beans. How would you calculate if they asked you to calculate the probability that the 2 jelly beans are red? Well, you could establish a sequence of letters such as RR and then calculate the probability of each of them, considering this data here. So what's the probability of getting one red? That's the number of favorable cases, which is the number of reds, X, divided by the total number of jelly beans in the bag, that is 10. Okay. Since they mention simultaneously here, that's an equivalent of without replacement. Let's consider this at the moment of calculating the probability for the second red bean. Now, if I didn't replace the first bean, that means red beans now are 1 fewer, X minus 1. And the number of total jelly beans is reduced by 1 too, so 9. Remember that since this sequence of letters can only be expressed in just one possible arrangement, this is equivalent to multiply by 2 factorial over 2 factorial, which is actually 1, okay? So that would be the total probability that the 2 jelly beans to be drawn are red in any order. And according to the statement 1, that equals 1/15. So here we have something interesting. We can simplify first. Divide by 5, 2. Divide by 5, 3. Divide by 3, 1. Divide by 3, 3. So you have this. X multiplied by X minus 1 equals 2 times 3. Because these 2 factors go to the other side of the equality. So you have to do a simple match of the terms. Here you have 2 numbers that have a difference of 1. And here also you have 2 numbers that have a difference of 1. So there should be a correspondence, right? We can say that X should be number 3 and X minus 1 should be number 2. So we have an answer to the question. Please avoid the incorrect approach of trying to solve a quadratic equation there. Remember that it's enough that we can do a match to see which positive value of X matches the correct expression or makes the equation true. You don't really need to solve the other value of X. Why? Because here we have this restriction. X of the jelly beans are red. That means that X is a positive integer because it's a count, a number of jelly beans. So we don't care about any other possibilities such as negative values for X. Just a positive integer 3 is sufficient, okay? So in this case, the first statement is sufficient to answer the value of X. Let's try and do the same for statement 2. How would you calculate the probability of getting 1 red jelly bean and 1 black jelly bean in any order? Okay, first begin with a sequence of letters, R and B. Then calculate the multiplication of the 2 probabilities. The first probability, we already know it's x over 10, multiplied by the probability of getting one black bean. How do you calculate that? Well, the number of black beans here, it's 10 minus x. These are the number of favorable cases. And what is the total number of cases? Well, 9, because it's without replacement. And we need to multiply that probability by the number of arrangements of this sequence of letters. Two different letters can be arranged in 2 factorial ways. So this should be the total probability of getting these 2 beans of different colors. And according to statement 2, that is 7 over 15. So now let's do some simplification. 2 with 10, so you get 5. 5 with 15, you get a 3. 3 with 9, you get a 3. So you can see that x multiplied by 10 minus x should be 3 times 7. Oh, you say, good. X must be 3 and 10 minus x should be 7. But could it be the other way around? What about if I put it like this, 7 times 3? Here, x could also be 7 and 10 minus x could be 3, right? Because the two numbers, x and 10 minus x, add up to 10, as 3 and 7 do. So you have actually 2 possible positive values for x. X can be either 3 or 7. And that is what we call not sufficient. So because of that, the correct answer choice here would be option A. Statement 1 alone is sufficient, but statement 2 alone is not sufficient.